Hi and welcome back to the second part of the control panel function tutorial using the Siemens S7-1200 PLC. In this video we will be editing the code we wrote in the previous tutorial to improve the overall functionality of the factory I/O control panel, so stay tuned. Okay, let's have a look at where we left off in the previous video. If you can remember, we added some rudimentary code for the start and stop button, as well as the emergency stop button. So if we press the stop button, it stops the entry conveyor from delivering pallets and boxes to the loader, but does not stop the loader or transfer conveyors from completing what they've started. Let's adjust the angle of the system to get a better picture of what is happening. Then let's start the system again. And then press the emergency stop button. As you can see, everything comes to a halt because this button could have been operated for safety reasons. Now let's disengage the emergency stop, which then starts up the system again. You can see the entry conveyor only comes back to life momentarily if a pallet was ready to enter the small loader conveyor before we press the emergency stop button. The rest of the system continues to operate once the emergency stop is disengaged, but obviously it won't continue for very long because the entry conveyor isn't running. All of this is not good from a safety point of view, and we need to add additional logic in to amend it. As it stands, the system can then start up again by pressing the start button, which we also need to make a change to. Okay, let's stop factory I/O and stop the PLC and go offline. Let's first open up the tag list and add a tag called temporary latch. And then enter. I will explain how we use this in a moment, but for now the data type is bool and the address M0.7, which are both assigned automatically straight after the previous data type and address. Okay, let's go to the first network and add a branch to reset the temp latch. So add branch, then change the coil type to reset. Then we can address it M0.7 and enter. Now let's move to network 2, the panel network, and see what we can do there. You can see in the second branch of the network that when the emergency stop is pressed, M0.6 is set, which then resets M0.5, system start. This means all the outputs, apart from the entry conveyor, will start again when the emergency stop is released. Although, as I mentioned before, should a pallet be ready to go onto the small loader conveyor, the entry conveyor will start up momentarily just to do that, then stop immediately afterwards, while the transfers, either left or right, continue. So what we need to do is prevent output starting again when the emergency stop is released. And to do that, I will use a rising edge trigger, Trig, activated by toggling the auto manual switch, input 1.4. That resets the emergency stop, but also sets the temp latch that can be used to prevent everything running again until the start button, I start, input 1.0 is pressed. So let's make the changes to the program. First, let's select the last branch in network 2 and insert an Trig from the bit logic operations. Scroll down, then select Trig and bring it down to the branch, and we'll name it Trig temp latch. then enter. Then on the CLK input, type in input 1.4 and select the input from the list. Then select the E&O output and bring down a normally open contact, and from the list find the Trig Temp latch and then select its Q. This ensures we only get a rising edge pulse on the output. Then after the emergency stop, we'll add a branch and then an output coil, and we'll address it M0.7 for the temp latch. Then we'll change it to a set coil and enter. Now let's just scroll up to the top of network 2 and bring down a normally open contact just after the iStart input and address it input I1.4 for the auto manual switch input. Then after that, bring down another normally open contact and address that M0.7 temp latch. What this ensures is the system will not start unless we are in auto and we have just switched from manual to auto. We can then reset the temp latch with another output coil, so change it to a reset and address it M0.7 and enter. Great. Now what we have to do is go down to the very bottom outputs network and add in the temporary latch in series with all the conveyor outputs. This will be a normally closed contact that will be made open when we toggle between manual and auto after the emergency stop is activated. So let's do that and then keep bringing normally closed contacts down and addressing them M0.7 temp latch. I'll be silent for a moment while I do that. I might speed it up a bit. So add them to the compare statements too, and that should be it. We don't do the same for the start and stop lights. Now let's download the program to the PLC, speeding this up a little as it takes quite a lot of time. Select load, then finish. That's done with no errors or warnings. Now let's go online, run the program and see what happens. Let's speed this up a little again. Okay, we are monitoring. Let's run factory I/O. I'll just make sure we are still connected. Yes, that looks okay. Let's go back and start factory I/O. Now, if I press the start button, nothing will happen because we are not in auto mode. So let's go into auto and then press the start button. And the system should start. Great. Okay, let's wait a while until we have a few pallets transferring. Now we'll just press the stop button to make sure that it's still working okay. The entry conveyor stops and the other conveyors will transfer the boxes until they have finished the job they were doing. Let's press the start button again, and as you can see, we can't start the system again until we toggle the auto manual switch. Maybe we should have labeled the switch something more appropriate, but it will do for this demonstration. So let's toggle the switch and then press the start button again. Okay, we're running again. This time let's press the emergency stop button and see what happens. The system completely stops, so let's disengage the emergency stop and toggle the auto manual switch again. Then press the start button again. Now let's press the stop button just as a pallet is detected by the beam sensor. The pallet is then loaded when the small loader conveyor is not busy, and the entry conveyor stops while the remaining pallets are transferred. Fantastic. And for the next step, we'll add in some code for the display and the reset button. But before I do that, we'll just go and save the project before moving on. I'll modify the name. Okay. That's now saving. Now let's stop the PLC and go offline and then add another network in. Just after the loading network, network 3, and this network will be network 4. In this network, we will enter code to count the amount of boxes fully loaded on the small loader conveyor. To do that, we will add an Trig, which is activated by input I0.3, I loaded. Then the output from the Trig will increment a counter to keep a record of the amount of boxes being transferred. So let's bring an Trig down into the network, and we'll name it Trig count boxes and enter. Then on the input CLK, we'll add input 0.3 I loaded and enter. Then on the ENQ output, we will bring down a normally open contact and address it with the Trig's queue. Let's find that in the list. Let's scroll down and there it is, Trig count boxes. Select that, then it's queue and enter. Let's close the bit logic operations and open up the counter operations and select the UpDown Counter and add it into the network after the queue from the Trig. Now we'll name it IEC Counter Count Boxes and select OK. Now let's add another branch in which we will add code for the reset part of the counter. I've just realized we only needed an up counter, but this will work just the same. We just won't make use of the CD countdown input on the counter, so it should be fine. Now let's add another Trig for the R input, and we'll call this one Trig reset counter and enter. The input for the CLK this time will be the reset button on the panel, which is input 1.1, I reset. And again, we need another normally open contact on the ENQ output to ensure we just get a rising edge pulse on the R input to the counter. Let's look for it in the list again. There it is, Trig reset counter, and select its queue and enter. Now what we can do is only allow the counter to be reset when the system is not running. So I will add a normally closed contact in series with the address M0.5 start system. Now we'll take the double arrow and bring it up to the counter's R input, and as soon as it turns green, we'll let go. There we are. We're getting there now. Now for the PV value, I'm just going to add in 1000. We have to put a value in, but we won't make use of the output QD should the system count that many boxes. The counter would just continue counting past that number anyway. The next thing we need to do is take the CV output from the counter and send it to the display on the panel, which has the address of QD100. I'm going to put that in the tag list too, so it doesn't just say tag 1. So let's take a look at the Factory I/O drivers screen to check the data type we need to enter in the tag list. Output QD100 is a double integer. So let's go back to the PLC tag list and name the output counter and choose dint for the data type, then QD100 for the address. It says already been used. It's probably in another tag list which I was setting up before, so let's check in the default tag list. I'm just going to delete that. Then take a look back in the other tag list. Let's scroll down and see. Yes, it's fine. It's not highlighted now. Now let's go back to the main OB1 and change the CV output address and select it from the list. There we go. Now I'm just going to add the reset light to the outputs network for when the reset button input 1.1 is pressed. Its output coil address is Q1.0 reset light. That's it. Now let's download the program to the PLC. Let's speed up the process on screen again because it seems to be taking forever when we really didn't want it to. Okay, select finish. Now let's go online and start the PLC running. And in Factory I/O, let's go back a screen and select Run. Now we are ready to press the start button and see what happens. As we can see, the system will not start unless we go into Auto, then press Start. Okay, we are running. Let's get a few boxes transferring to see the counter going up. Then I can try the reset button. As you can see, that doesn't reset the counter as the system is still running. So let's press the stop button to stop the system running. Then we can press the reset button again, and this time the counter is reset to 0. Great, that works fine. Now we can't start the system running again until we toggle the auto manual switch. Then press the start button. Then the boxes start counting again. Now let's test the emergency stop. The system stops completely. Let's disengage the emergency stop, toggle the auto manual switch, and press start again. And lo and behold, the system all starts up perfectly again. Let's just watch it for a while to make sure. Yes, it seems fine. Right, let's press stop and stop factory I/O. Then let's save the program. Stop the PLC and go offline. Great, that's it for this video. And in the next video, the final part of the panel tutorial videos, we will add another light to the panel in factory I/O and make use of the 2 Hz PLC clock system bit to flash the panel light on and off when the emergency stop button is pressed. So please feel free to comment below and subscribe and click the bell so that you'll be informed as soon as more videos are uploaded. Thank you for watching and see you in the next video. Bye for now.